All right, last time we were looking at finding all vertical and horizontal asymptotes of this function. And we got a little bit into it. So what did we do last time? We started with labeling AN and BM. What are AN and BM?
Numerator.
Leading coefficients, right? Those were our leading coefficients. And so with the leading coefficients, what do we know about finding the asymptotes?
If they're equal, you do like the.
If what's equal?
The degree.
The degree. So what's the degree of the numerator?
2.
Right, because of this. What's the degree of the denominator?
2.
2. They're equal. So what does that give us for a horizontal asymptote?
1.
So give me the equation for the horizontal asymptote.
X equals y equals 1. Y equals 1.
Is it horizontal or vertical?
Horizontal.
Horizontal. So does it need an x or a y?
Y.
Y.
Yeah.
So y equals 1 over 1. It's 1. So that's
Did
our
you already
horizontal.
write all this?
There's our. We did this last time.
Why is there a sheet over it?
Because I'm going bit by bit. Okay.
Bit by bit.
But we had some trouble with finding the vertical asymptotes. Why?
Because we forgot how to.
How to do
base
it?
0.
How to do it? No, it's because all of these rules have the presumption that n and d don't have any factors in common.
Oh.
So we had to factor the numerator and the denominator. Remember doing that?
Yeah.
All right, so we need to factor the numerator and the denominator. So what does the numerator factor to?
Nothing.
This is all I have from last class.
X minus 1. X minus 1.
So for this, for the right hand, like the right part of the factoring, I can have 1 and 2 or 2 and 1, right? Factors of 2.
Minus 1 plus 3.
So and then they have to multiply together to give minus 2. So I need a plus and a minus, and they have to add together to give plus 1. So I'm going to say plus here and minus here. Sam, let me check this. FOIL this for me.
X squared and then
Outside
Does it
x
say
to
AN?
2x
plus 2x and inside.
all over negative.
No, FOIL. First, outside, inside, last.
Yeah, I know foil. Minus 1x.
Minus 1x,
And then minus 2.
minus 2. And does that give me x squared plus x minus 2?
Yep.
Yeah, once I combine like terms, yes. And,
Okay, never mind.
okay, and then let's factor the denominator. So I need x's here because they're going to multiply together to give x, right?
X minus 3 plus 2.
X minus 3, x plus 2. Eric, help me verify that.
X squared
X squared
plus 2x
minus what?
plus 2
Plus 2x
minus 3x
minus 3x minus 6. Does that give me x squared minus 6, or x squared minus x minus 6? When I combine like terms? Sorry, does that give me x squared minus x minus 6?
Oh no. Yeah. Oh wait, yeah.
I see confused looks.
Yeah, because you would do 2x minus 3x.
Right.
And that's 1x or x. Or
Right.
X
So,
squared
Eric-
plus x minus
Yes.
6.
Eric,
Or
help me.
minus.
Let me combine like terms. X squared. Sorry? Combine like terms. So how many x squared terms do I have
It is.
in this?
You only have to one.
Only one x squared terms. How many x terms do I have?
X term you have two.
I have two x terms. So add them together, please.
And
2x minus 3x is what?
is minus 1x.
Yeah. Do I need to write the 1? No, the 1 is implied. And then how many constant terms do I have?
1.
Just one constant term?
Yeah,
Minus 6. So did I successfully factor my denominator?
Yes, you did.
Yeah, that's this, right?
So the M, I'm curious about the N and M. Those are just the coefficients?
N and M are not the
How
coefficients.
are you erasing all of it?
A sub n and A
Yeah.
sub m, B sub m are my coefficients. Those are my leading coefficients.
So
N
those are the numbers in front.
and m, right? The numbers in front. So there's my 1 for A sub n, and there's my 1 for B sub m.
Okay.
What are my n and m? What's n?
Are those the? It's not the coefficients because.
Not coefficients. What do we describe n and m as being?
Wait, I have it.
Yes, it's the degree. These are the degree.
So then, what? How do you find the degree?
How do you find the degree?
It's the like x squared. Like choose the degree. Power.
It's the what power?
So then, when n be 2 or the highest power.
Highest power.
So then, when n be 2. If
So n is 2. It's from here.
Yeah.
And m is 2.
But
It's
you
from
didn't- You
here.
just left it blank.
What?
Horizontal n equals 2.
Sorry.
Yeah, that's us confused.
Sorry.
And then that's how you find the horizontal because
Gotcha.
you just divide those. If they're
And
equal. Yeah.
If they're equal, then my little chart of my rules say then I can use this to find my horizontal asymptote. It's the ratio of the leading coefficients. Right. So we were trying to see if we can factor and reduce this expression. Can we reduce it?
Yes.
Can we simplify? How are we going to simplify?
X minus 1 over x minus 3.
How did you get there?
Because the x plus 2 cancels out.
X plus 2 cancels out, right? So that leaves me with f of x equals x minus 1 over x minus 3. And we're at what stage of trying to answer the question? What stage are we at, Warren? Where are we? What are we trying to do?
We're trying to find the vertical.
Yes.
So
Yes, and what have we done so far?
factor.
No, what have we found so far? Out of finding vertical and horizontal asymptotes, what have we done so far?
Found the horizontal.
We found the horizontal asymptote. What is it?
It's y equals to 1.
Y equals 1. Right. So where are we?
There.
Where? Don't point it to the screen. I'm recording this for your fellow classmate.
There.
Where are we? What are we trying to find?
Oh, we're finding the vertical asymptote.
Yeah, now we're on the finding the vertical asymptote. How do I find the vertical asymptote?
You set the denominator to 0.
The vertical asymptotes are found at the zeros of the denominator. Right. So I'm going
Was
to.
that all horizontal asymptote?
So
Is that-
this is all in preparation for vertical. So I'm sort of on the vertical stage. I'm finished with horizontal. Now I'm trying to find the vertical asymptote, and I find the vertical asymptote by setting the denominator equal to 0, finding the zeros.
X minus 1 over x minus 3 equals 0.
No, this
Or
is
do you do x
n.
minus 1 over equals 0.
This is n, and this is d, numerator and denominator functions.
Oh, so you do x minus 3 equals 0.
So x minus 3 equals 0.
Is it
So
always denominator?
it's always a denominator because that's the idea of the vertical asymptote is that's going to be my excluded value of x, if that makes
So then
sense.
wouldn't it be positive 3x equals 3?
X equals 3.
So vertical asymptote is 3, and then your horizontal asymptote is y equals 1.
Yeah, X equals 3 is my vertical asymptote. So don't just answer 3.
Isn't there a whole at 2?
Can you explain the whole better thing? I
So
taught that. Yeah.
right. So if you graph this original function, it's going to look like what you tell me what it's going to look like. We might just go to Desmos and try.
I'm sorry. Can you repeat that?
So what? Let's just go to Desmos. Yeah, Carlo.
And so if like the numerator, once we factor the numerator and denominator, and what if they're like, it's really long, like a lot of different factors, and they don't like cancel each other out. What's the next step?
If they don't cancel each other out,
Yeah.
then the only reason why we're looking for factors in common is because our list of rules say provided that n and d have no factors in common, then all of these rules are true.
Oh, okay.
All these rules are the way to find the vert and horiz asymptotes.
What if they?
Don't have any factors in common, then just go for it.
Okay.
She was just asking how much time we had left in class, and I was like, there's a countdown clock
There's a countdown clock. Why did I make that clock?
to give us hope.
Because last year they tricked you into getting out of class.
Because last year my honors algebra 2 class took no end of delight, and you know some of these people, you probably have an idea who I'm talking about, of tricking me into how much time we had left. Oh, Mr. Shadow class ends at 10. I'm like,
Wait, where's the countdown clock? Right there.
so I made that countdown clock in Python to foil
That's so silliness.
my evil algebra 2 students.
They said you should get a 10.
For example, in maybe class went to 10-10. So that'd be like, and I fell for it a couple times.
That's silliness.
That's on my part as well, but
Were you like confused? I'm like.
And now he lets us out 25 seconds early.
so now I know I have a minute and a half. I can still tell you something. So the question is, what?
What? I stare at that clock all day. Every time I look over, he's like
I
looking
know,
at me.
I know.
I did that clock.
What does this function look like? What are we expecting it to look like?
No, sir. I don't understand.
Like,
Yeah, I
the
don't.
the shape of the
Can
function.
you tell us about the holes?
I'm getting there.
Okay.
This is the long way around.
I just want to make sure you get
So
there eventually.
I don't mean just look at the function and know what the graph is going to look like. I'm going to have an idea of what it looks like. So what do we know about what it should look like?
There's going to be a vertical asymptote at 3.
1, 2, 3. I have a vertical asymptote and a horizontal asymptote at
1.
1. So it's going to have, what does a horizontal asymptote mean in general? What's the idea of the horizontal asymptote?
The line.
Horizontal asymptote. Tell me about it.
It's a dotted line.
Infinity.
So as x approaches infinity, the function approaches the asymptote. So it might end up looking like this. Could look like this. So we have an idea of where the we know where the asymptotes are, but let's graph it and we'll come back to it and answer my bigger question of what it should look like. Where are my asymptotes supposed to be?
3 and 1.
No, 3 and 1 is not an answer for asymptotes. Asymptotes have an equation. There you go, y equals 1. And I'm going to make that a dotted line. I'm going to press and hold the little squiggly line there. There's a dotted line. And where's the vertical asymptote?
Up there.
That's 3.
I see it. I see what's going on.
3.
I see what's happening.
That's 3.
Yeah.
I understand it now.
Good job.
Okay. And what's the simplified version? What was our factored version?
1 over x minus 3.
X minus. Tell me what the denominator is supposed to be. X minus 3. This is kind of what I was talking about when I said, what should the more complicated, unfactored function look like?
Where did the right go?
So if I click on the squiggly line, the red squiggly line, I can hide it or show it. So if I show the simplified version,
Oh, so are we showing that they're the exact same thing?
Yeah.
Oh, okay.
Are we supposed to be able to like look at the original one and like, oh, that should be like
so no. So when you look at the original equation, the unfactored version, then you can get the horizontal and vertical asymptotes out of it. So that's what we have so far. If you weren't using your calculator, graphing tool, or Desmos, then you would just pick some points and make a chart, and then you could start to build this. But you know that it's going to approach the vertical asymptotes. You know that it's going to approach the horizontal asymptotes. So you have some idea, but we sort of didn't know if it was going to be quadrant 2 and 4 or quadrant 1 and 3, that type of thing. So Sydney, to answer your question, while you are, if you are using this original function, what excluded values of x do you have? Sorry. If you look at the factored version to see what the excluded values of x should be. The factored version. Here's my factored version.
Yeah. I'm confused with the excluded factors of like.
Where does if you use this unreduced, unsimplified version before we cross out the x plus 2's, if I use this version, what values of x would cause this to be an invalid
A
function?
positive one, a negative.
Positive what?
Positive 1.
No. You can have 1 in the numerator. It's not a problem. I mean, you can have 0. You can have 0 in the numerator.
Can't have 0 in the denominator.
Can't have 0 in the denominator. So what values of x would cause this to not be okay?
Anything like a positive 3?
Positive 3x equals, so x can't be positive 3
And x can't be
and x can't be
a negative.
negative 2. So this is the source of the whole. This is the source of the whole, is using the more complicated, unsimplified f of x
So
before
the
we
MIDI
cross this out.
factor,
So what?
like the MIDI factor.
I don't know what you're saying.
There's like 3 stages of factoring. There's like the original equation,
Mhm.
and there's like before you take everything down and simplify it, which
Yeah.
you got x minus 1 over x minus 3. So that's like the middle.
Right. These two are truly equivalent. These both have the same.
So then if it's
excluded
asking
values.
like identify the whole, you would say 3 and negative 2, or would you say x?
Three does not reduce, so it results in a vertical asymptote. Minus 2 does reduce,
So it's x equal 3.
so
So the whole would be negative 2.
the whole would be at x equals negative 2. So it would be
So if it cancels
it would be
out,
2 and f of 2, wherever 2 is, or minus 2. Sorry.
So if it cancels out, that's where the whole is.
Yes.
Okay, that's what I needed.
All right. Let's do an example.
Yeah.
Yeah.
Except for vertical asymptote.
Horizontal asymptote. Vertical asymptote is
3. X equals 6.
x equals yeah.
Vertical is y equals 1.
Right.
The whole was x equals negative 2.
Yes.
And the
X equals
range
negative 2, comma.
negative, so wait, negative infinite, comma, 3, in parentheses, u, and positive infinite to 3, negative 3, and then u, and then it would be, there'd be the vertical, the horizontal asymptote, or no?
No, you don't mind with horizontal
Okay,
asymptotes.
that's it.
Yep. So you should account for vertical asymptotes and holes. Yep.
Okay.
Yep, good job. All right, so here's an example that says, a utility company burns coal to generate activity. The cost, C, in dollars of removing P% of the smokestack pollutants is given by this formula. C equals 80,000 P over 1 minus P. And this works for P, it runs from 0 to less than 100. So sketch the graph of this function. So I have written a condensed version of the rules that,
Go back.
okay, hold on, here's my condensed version of the rules. So to start with the sketching, I need to find the vertical and horizontal asymptotes. So which one want to do first? Are you writing notes?
Horizontal asymptote.
Let's do horizontal asymptotes. Where are the horizontal asymptotes?
Y equals,
How do I find?
if
It's
n is
powers.
greater than n,
So
but all of the powers are equal.
and what is n? What is m?
N is 1.
And
Where did you get that?
There's no
Because
power.
there's none.
Well, it's an implied one.
Yeah, so it's applied 1.
So n equals 1, and m equals
One.
Implied one as well.
it's implied
So
1
it's
here.
1 over 1, and that's
So it's 1 over 1. So the horizontal asymptote is at,
Y equals 1. Or Y equals 0.
It was 80,000 P over, like, isn't it?
Y equals AM over BM. which
Right.
is-
Which would be the leading coefficient of the highest power.
Yeah,
And it's all one, so
Yeah.
it's just that.
so it's just that. 80,000 over 100.
I disagree.
I think the horizontal asymptote was 1. 1 over 1, it's an equal ratio.
It's, where did you get the 1?
It's an implied 1, n equals 1, m equals 1.
No, why is not n over m?
Is it 80,000
AM over
one?
BM.
So then wouldn't it be undefined or 0?
AM.
Because there's no x's, there's no...
So where do I get my an? Where do I get my an over bm?
The numerator and the denominator. And it's
What
the
are
leading
they?
coefficient and
Is
then
it
the...
80,000 over 1?
Over 100 must be, I guess it's just the function.
Yeah. But there's literally the function.
No. So what's the purpose of writing my numerator this way and my denominator this way?
So that you can see your terms.
Hmm?
Like you can see that.
Yeah. So how is this written? What form is this written in?
General.
General form. General form means what?
Decreasing powers.
Decreasing powers. Is my original C written in general form?
No.
So how do I write C in general form? What's my numerator?
80,000.
80,000 P, and there's no other terms. That's already in general form. What's my general form?
100 minus 5.
How did you pull those rules out of your behind?
We had written them at a different time, you just copy them and paste it into.
So the whole point of N and BM being special is they're the leading coefficients. What does leading coefficient mean? It means
P minus 100.
Leading coefficient is the number in front of
Is the
the...
variable.
What do you make it like negative P minus
There you go.
100, and then you pull out a
There you go.
negative? Or yeah.
Wait, why do you have to flip that over?
because I'm not supposed to pick out a sub 0 or a sub 1 or a sub 2 or a sub whatever. For this formula, I have to have the leading coefficients. That means I have to look at how it would be written in standard form, in general form.
But doesn't the number usually go in front of the coefficient?
I can write it this way, but 100 is not my leading coefficient.
Oh, negative is.
Negative
One.
1,
Oh, sorry.
right.
You have only written 8,000 feet.
Yeah.
Okay, thank you.
Yeah.
Thank you. Squeeze in an extra zero. It's not an exponent. Okay, maybe I have to fix that a little bit.
Super nice to be that, yeah. Look at that.
I have movable text. So what's my A sub n and my B sub m?
1 over -1.
A sub n is what? B sub m is what?
Wait, 80,000 feet.
80. No,
Oh, wait, just 8,000.
80,000.
Over -1.
And B sub m is -1.
So it would be negative 80,000.
Yeah.
And that's the vertical or the horizontal?
Horizontal.
So it would be y equals.
That's a very, like, high horizontal.
Yeah. What's my vert?
Your vertical.
100.
Wait, what?
P equals 100.
Oh,
Can you figure that out? Yeah.
Why is it equals 100?
you said that.
No, no, no.
Zero.
No, no, no. Carla, how do I find my vertical asymptotes?
Okay, yeah, you just set it to 0. 0, the denominator.
Set the denominator equal to 0. It's 100 minus p equals 0.